Hello class, we are now ready for lesson 5 in Math 113, and I'm going to start with page 13 to give you the notes here. So grab your book and open it up to page 13. We're going to be talking about radical equations, and you have to isolate the radical. For example, in square root of x plus 2 plus 4 equals 10. My variable is right here, so I need to isolate this guy. So I'll need to move the 4 over here. To move it, I'll have to subtract it from both sides. So now I have the square root of x plus 2 is equal to 6. So to solve them, when you get the radical expression on one side and all the numbers on the other side, to solve it, you square both sides, or cube whatever number goes in here for the index. All right, so when you square this, the square root of a number times itself is just that number. So x plus 2 comes out from under the radical sign, and 6 times 6 is 36. I need to isolate the x, so I subtract 2 from both sides, and x is equal to 34. So let's check it. 34, back up here. 34 plus 2 is 36. The square root of 36 is 6 plus 4 is 10. So yes, that one works. If it didn't work, it would be an extraneous root. And when you tried to check it, it would be false. Okay, that's the only example on that one. Just be careful when you're doing that. Oh, I also want you to remember that if you had like the square root of x plus 4 is equal to -7, that would be a no solution, because we're not going to use imaginary numbers on this assignment. And always isolate this term right here. Move everything over if there's something to move. Okay, now, find my eraser here. I thought I was all ready. We're still on page 13, and now we're going to look at quadratic equations. Remember, quadratic equations have a square in them, for like x squared plus 6x plus 8. That is a quadratic because of that square right there. So there are different ways to do it. You can factor and use the zero factor property. You could try the square root property or the quadratic formula. So on example 1, this is example 1, and I look at that and I say, oh, I think I can factor that. All of them are plus, so both of these will be plus. 4 times 2 is 8, and 4 plus 2 is 6. Well, that worked out very nicely. Okay, and that's equal to 0. And remember, once we get to there, we say that one of these guys has to equal 0. So we go x plus 4 is equal to 0, or x plus 2 is equal to 0. If this is the case and I subtract 4 from both sides, x is equal to -4. If this is the case and I subtract 2 from both sides, x is equal to -2. Now we need to check those to make sure they work. So I'm going to take this -4 and I'm going to bring it all the way back to the original. -4 squared is 16. Plus -4 times 6 is a -24, plus 8. Is that equal to 0? Yes, it is. So that one works fine. Now let's take the -2 back up here to the original equation. So -2 squared is 4, and then -2 times 6 is -12, and then plus 8. Is that true? Yes. So they both work, so you have two answers. -4 and -2. And those of you who have been highlighting or making your answers darker when you send it to me on my phone, that is so awesome. Okay, let's go on to the next example. On this one, I have x plus 3 squared equals 16. So on this one, I'm going to use the square root property. Square root property, and you can see it there on that page. It says that if x squared equals a, then the square root of x squared equals plus or minus the square root of a. And that would just be x is equal to that. So let's look at this. Can I take the square root of this and the square root of this? I can. And that would give me x plus 3 equals plus or minus 4. Are you with me? Took the square root of both sides. So I have two answers. X plus 3 is equal to 4, or x plus 3 is equal to -4. If this is the case and I subtract 3 from both sides, x is going to be equal to 1. If this is the case and I subtract 3 from both sides, I'm going to get x is equal to -7. Once again, I need to see if they work, so I'll go back to the original, which is x plus 3 squared equals 16. I just realized I didn't write that. So if I put 1 over here, 1 plus 3 is 4, 4 squared, 16. Yay! If I put -7 there, -7 plus 3 is a -4. -4 squared is equal to 16. So both of those work, so you'll have two answers for that one. Okay, I hope everybody's staying well. I know this is a kind of a tough time to live through, but we will all make it. So, and then the third example on that page is x squared plus 6x equals 3. Let's change it to where it has it is equal to 0 so we can see if we can factor it. All right, I don't see anything that I can do with that -3 to get a 6. Do you? Yeah, I think we're going to have to use the old quadratic equation. And that's written for you up above there on page 13. So we're going to have -6 right there for b, plus or minus b squared, which would be 36 minus 4 times a, which is 1. A is right here, times c, which is a -3, all over 2a, which is just 2 this time. So I've got 4 times 3 is 12, a negative times a negative is a positive, so 36 plus 12 inside there, -6 plus or minus, and then, oh, that's over 2. I need to put 36 and 12 together. I believe that's 48. -6 plus or minus the square root of 48 over 2. Take your 48 and see if it'll factor. What have I got here? 8 times 6, 4 times 2, 2 times 2, and 2 times 3. So I'm going to have 2 to the third I'm sorry, 2 to the 4th. 2 to the 4th times 3. Well, 2 to the 4th is 16, and the square root of 16 is 4. So I'm going to have taking out a 4, I'm going to have a negative 6 plus or minus 4 times the square root of what was left in there of 3, because I took all of these out, over 2. Notice if you can divide 2 out of this one, and out of this one, and out of this one, you can do that. So it's going to be negative 3 plus or minus 2 times the square root of 3. And you can leave it like this, or if you want to go the extra step and put it into a decimal, I don't mind. The only ones I want you to be sure to do that on is when you're solving for a certain time or solving for a certain distance. Then go ahead and put it in decimal form, please. So that takes care of those. And down there at the bottom it says solving rational equations, and we're going to be doing that now on the back side. Page 14, rational, remember that means you have a fraction that involves a variable on the denominator. And remember, the denominator cannot be negative. That is called a restriction. All right, so be sure and remember that's a restriction. And remember proportions. We're going to use proportions. So this is the easiest way to solve a lot of problems. If you can get two fractions equal to each other, you can cross multiply. AD is equal to CB, and then just solve. So let's look on page 14. Radical and rational equations can produce quadratic equations. Sometimes we'll have to use the quadratic formula to solve the resulting quadratic equation. So A is the square root of x plus 2 is equal to x minus 3. Now remember, to get rid of that radical sign, we have to square it. And if we square this side, what do we have to do to this side? You're exactly right. We have to square it. We have to be fair. So when I do this, I'm going to have x plus 2 is equal to, and I square that, foiling it, x minus 3 times x minus 3 is going to be x squared minus 6x plus 9. Excuse me. So now I'm going to move everything over so that I'll have it equal to 0. So I'm going to move everything over to that side. X squared, and I'm going to be subtracting x over here, so I'm going to have a negative 7x. Then I'm going to move that 2 over there, and I'm going to have a plus 7 equals 0. I don't see any way we can factor that except use that good old quadratic formula. So you're going to end up with 7 plus or minus the square root of 7 squared I'm sorry, this down here, never mind, it is negative x. Negative 7 squared minus 4 times a, which is 1, times 7. So that'll be 49 minus 28. All of that is over 2. And so I have 7 plus or minus, and that is 21 when you subtract that. So the square root of 21 and all of that is over 2. And that, my friend, is your answer. Unless you want to take it down to the decimal, which I don't care if you do or not. If you want to, that's just fine, but this is fine too. Excuse me. And the next example is x plus 2. This is a rational equation. X plus 2 over x plus 2 equals x minus 2 over 3. So, first of all, what can x not be on the bottom here? X plus 2 cannot equal 0 because that's a restriction. So if I subtract 2 from both sides, I'm going to have x cannot equal to negative 2. So remember, that is our restriction. Now, I see that I have two fractions equal to each other, so I'm going to, excuse me, cross multiply, and I'm going to have 3 times x plus 2 is equal to x minus 2 times x plus 2. Okay, I'm going to distribute here. 3 times x is 3x. 3 times 2 is 6 is equal to, and I'm going to multiply those together. The middle terms are going to cancel out because I have a minus 2 and a plus 2. So I'm going to have x squared minus 4. Now I need to get all of this together. So I'm going to bring my x squared is positive over here. So I'm going to bring my 3x over to that side, which makes it a negative 3x. I'll bring that over there, which is going to make it a negative 10. That's equal to 0. Okay, I believe I can factor this and say x and plus 2 and subtract 5. Would that work? Okay, so if this is true, x plus 2 is equal to 0, then x is equal to negative 2. If this one's true, x minus 5 is equal to 0, then I add 5 to both sides and x is equal to 5. Now, wait a minute. What do we know about this guy? He is illegal. He cannot be on the bottom. So he is what we call an extraneous root because he doesn't work. He makes a false statement. Can't be 0 on the bottom. Does 5 work? Yes. 5 plus 2 is 7 over 7 is equal to 5 subtract 2, which is 3 over 3, and that equals 1. So my answer is x equals 5, and you just write x cannot equal negative 2. So that'll be the answer. Always put the extraneous roots on there. That just means you have to go another step, right? Okay, we are now ready for example C on page 14. Hope you got copying these down. Just put me on pause if you get behind. So on this one, I have 1 over x plus 1 over x squared is equal to 5. I need to have common denominators to put those together. So what I'm going to do is look here at this x squared and say, you know what, if I multiply by x over x, I'm going to have x squared on the bottom. So x times 1 is x. X times x is x squared plus 1 over x squared. And I can put those together and I'll have x plus 1 over x squared. And that's equal to 5, equal to 5, and equal to 5. And I want to make that into a fraction. Why? Because if I can get just a simple fraction over here, I can cross multiply. So I'm going to have 5x squared equals x plus 1. So I'm going to bring that up here. 5x squared minus x minus 1 equals 0. Always set it up equal to 0. And I'm quite sure that you can put this into the quadratic equation knowing that let me find out where I'm at here. 5x squared okay, so minus x and minus 1. I miscopied that problem. This is supposed to be a 2 right here. Thank you for telling me that. 2 right there, which makes a 2 right there, which is going to make a 2 right here, which is going to make a 2 right here, which is going to make a 2 right here. Give you a second to get those erased and fixed on yours. So I have A is equal to 5, B is equal to -1, and C is equal to -2. If you put that in the quadratic equation, going to have 1 plus or minus the square root of -1 squared minus 4 times A, which is 5, times C, which is -2, and when I put that together, that's going to be 1 plus 40. Oops, sorry about that. 2 times 5 here. So that's going to be 1 plus or minus the square root of 41 over 10. And that is your answer, unless you want to do a little extra work and work it on out to a decimal. But again, I don't expect that. Thank you guys for staying on top of this. And without you being in the room with me, it's kind of hard for you to tell me when I write a problem down wrong, so I just have to go back and fix it, and I apologize for that. But it happens. It happens to me, and it happens to you once in a while. Example D on page 14. 1 over x plus 2 over x plus 3. And that also equals 5. All right, so the first thing I'm going to do is common denominator. So I'm going to have to, this and this they don't have anything in common. So I'm going to multiply this side by this one and this side by this one. So I'm going to have x plus 3 over x plus 3 times 1 over x plus 2 over, and I have to multiply this one by x so I'm going to have, multiplying those, I'm going to have x plus 3 over x times x plus 3. And over here, I'm going to have plus 2x over the same thing here. So we double check that I copied that correctly. 3x. Okay, so up here, I'm going to add those together. 1x plus 2x is 3x plus 3. And on the bottom, I'm just going to leave that like it is. X times x plus 3. And that, my friend, I didn't bring that down, but it's equal to 5. Equal to 5, I'm going to set it equal to 5 over 1. Why? Because I like to do the proportions. So 1 times this, which would be 3x plus 3, is equal to 5 times x plus 5 times x times x times x plus 3. So let's go ahead and distribute over there. So I'm going to have 3x plus 3 is equal to 5x squared plus 15. Make sure I copied that all right. Plus 5 squared plus 15 equals 3x plus 3. Okay. Yep. So I have, there's my positive 5x squared. So I'm going to go 5x squared. I'm going to bring that 3 over there. So it's going to be a plus 12 because 15 subtract 3 is 12. But actually, let's bring that 3x over there so we'll have it in the right form. Negative 3x plus 12 equals 0. Why did I put it in that form? Because that's our quadratic form. And that way I can know that A is 5, B is negative 3, and C is 12. And when you put that in a quadratic equation, I'm going to come back over here because it's a little bit lengthy. You'll have negative b would be negative 12 plus or minus the square root of 144, which is 12 squared, minus 4 times 5 times a negative 3. And if you put all that together, we'll get, okay, and then on the bottom it's 2 times 5. So we have negative 12 plus or minus the square root of 204 over 10. Well, when I factor that 204 down, I'm going to have negative 12 plus or minus the square root of 4 times 51. But notice that 4 is a perfect square, and I can pull a 2 out. So I'm going to have negative 12 plus or minus 2 times the square root of 51 over 10. I should have brought that down. But okay, so I look at these. Nothing I can do with that 51. But I see this number and this number and this number all have a 2 that I can take out. So I can have negative 6 plus or minus the square root of 51 all over 5. And that's your answer. Okay, now we have 2 more problems. Let me see how, oh, this is going to be kind of a long one, but it's going to be less than an hour, so that's not too bad, I guess. So, do you remember the Pythagorean theorem? Mr. Pythagoras said that in a right triangle, a squared plus b squared is equal to c squared, where this is a leg, and this is the hypotenuse. So here's my right triangle, and this leg it says one leg of a right triangle is 10 inches longer than the other one. I don't know how long that one is. Someone call it X. Is that right with you? I know that this one's 10 inches longer. 10 inches longer would be X plus 10. And I know that the hypotenuse is 30. So I'm going to put it in the a squared plus b squared equals c squared. A squared would be x squared, and it doesn't matter which one you do first. You're going to get a same thing. Plus x plus 10 in parentheses squared is equal to 30 squared, which happens to be 900. So when I work all of this out, I'm going to have x squared plus x squared plus 20x plus 100 is equal to 900. Okay, I need to put my terms all together to get 0 over there. So 1x squared plus 1x squared is 2x squared plus 20x. And if I subtract 900 from both sides, that's going to give me a negative 800 here. And that's equal to 0. Now let's just make this a little simpler by dividing every term by 2. So I'm going to have x squared plus 10x minus 400 equals 0. Give you a second to look at that. Now, you're going to put that into the quadratic equation with a equal to 1, b equal to 10, and c equal to negative 100. And when you put that in there, you're going to end up with negative 10 plus or minus the square root of 1700, all over 2. Now on this one, yes, you need to work it out to a decimal. And when you do, you'll have one positive number and one negative number, and your answer has to be positive, so it's going to be 15.616 inches, because distance cannot be negative. All right, one more. Aren't you glad you learned how to do that quadratic equation? You're going to be using it here again, by the way. All right, so one person takes 2 hours longer than another person. Well, first of all, this is the work equations. And if you remember from 112, we had 1 over the first rate plus 1 over the second rate equals 1 over the total. So the first guy, one person takes 2 hours longer than the first person. So the faster person, let's call him X. And the slower person is going to take X plus 2. And we're going to call these hours. And they can get together, they can get the job done in 4 hours. So that's the total, 4. So we're going to have 1 over X, which is how the faster one does, plus 1 over X plus 2, which is this guy. And that's going to be equal to 1 over the total, which is 4. Okay, so let's do it. First of all, let's add these two together. I'm going to have to multiply this guy by this. I'm going to have X plus 2 over X plus 2 times 1 over X plus, and I've got to multiply X over here, 1 over x plus 2 times x over x is equal to 1 over 4. So then when I multiply those, I'm going to have, do you mind if I bring it over here? Hope not. I'm going to have x plus 2 plus 1x would be x, and that's all over x times x plus 2. Okay, so I'm going to have 2x plus 2 over x squared plus 2x is equal to 1 over 4. And now I'm going to cross multiply. 1 times x squared plus 2x is just that. And then I have that equal to 4 times 2x plus 2. So x squared plus 2x is equal to 8x plus 8. So I'm going to have x squared, bring this over here, minus 6x minus 8 equals 0. And I don't believe you can factor that, but you can use a quadratic equation. And you're supposed to find out how long it takes the slower one. And I believe that'll be 7.123 hours. Now, on your homework, the one that has it equal to 30 minutes, you need to write that as 1/2 because you have to have everything in hours or everything in minutes. So that would be half an hour. So you're going to have to set it up to 1 over 1/2. And if you go 1 divided by 1/2, you're going to get 2. So it'll work out pretty nice for you. And that, my friend, is it. Your homework is on page 15 and 16. I believe there's 20 problems. And if you need any help, you know my number. Have a great weekend. And I will see you later.